conditionally convergent. And I'll show you that at the end. First, I'm going to show you how to identify it, then I'll show you what it means. Okay? Okay. So, basically, if you have your series and you make a new series, so if you make this whole new series by taking the absolute value of the original series, if that new series converges, okay, so if this guy converges, then this guy is absolutely convergent. Now, let's say that this guy diverges, okay? So I went from here and I said, it diverges. Then we go back to the original series. If the original series converges, then we are conditionally convergent. I'm going to make a little flow for us, okay? Because this kind of looks weird. So, if it asks you, are you conditionally, absolutely convergent, or divergent? This is our flow. We are going to make a new series. This is a whole new series. That series can do one of two things. It can converge, or it can diverge. Yes. If it converges, then your original series is absolutely convergent. So this is our new, this is our original. Okay? If it diverges, then go back to the original. And that now can do one of two things. What are the two things it can do? Converge or diverge. If this now, the absolute new series, if that diverged, but the original converged, then the original is conditionally convergent. If the new series diverged, and the original series diverged, then this original just diverges. No conditional, no nothing. So those are the three outcomes that could happen. Okay, so again, I started to connect one. So first, make a new series. Second, see if that new series converges or diverges. If it converges, you're done. If it doesn't, then go to step 3. See if the original converges or diverges. Okay? That would be kind of my flow of what I would do. Now, if it just asks, says converge or diverge, do I have to create a new series or anything? No, you're basically already on step 2. Okay? Okay, so no new series. Okay, you just do what we've been doing. part if it asks for absolute or conditional.
Is the new series just the absolute value of the other one?
Yes. Yes. We take the absolute value. So it's no longer with the limit or the direct or anything like that. It's always the absolute value. Good question. Okay. Good? Okay, so let's look at the first one. It says determine if the following series are convergent or divergent. If convergent, classify as absolutely or conditionally. So I see that part. As soon as I see that part, I think I first have to do what? Yeah, make the new series. So my new series is taking this guy and taking the absolute value of the inside. And some of you guys will skip this step and go right to this one right here. So some of you guys will skip that and they'll go right to this part. When taking the absolute value, what's it doing to this alternating part? It's just making it always equal to what in the numerator? 1. And down here, as I plug in 1, 2, 3, 4, that denominator is always positive. So do you see how my absolute value bars have dropped off completely? Yes? Okay. So this is my new series. And now I want to see if it does what? Converges or diverges. Okay, let's go back.
You drop the absolute value bars since you're starting.
Right. Yeah, so I don't need the absolute value bars anymore. This is always positive now. And that part up here just always makes it a 1. Okay? Yeah. Okay. So this is our new series. So what does it do? Diverges by what? Anybody say it diverges by the integral test? Okay, fine. And that one diverges. So this tells me, if this diverges, what does it tell me about the original? Okay, so it only tells me that it is not what? Okay, it's not absolutely convergent. Does that make sense? And this was our original. So that's all I know so far. I have left to determine, well, does it just diverge or is it conditionally convergent? Yes? So now I take the original series. Okay, and what test are we going to do on this? The alternating series test. Step 1 is to take the limit. It's always is what happens. And approaches what? What? Always, and approaches infinity of the part without the alternating series. Yes? I got 0. Does that tell me anything? No. Tells me go on to step 2 in Austin's words. Next step says, hey, show that the next term is always smaller than the previous term. And is that true for n greater than or equal to 1? Do you need to keep going, or can you say, hey, yeah, that's true? Okay, so this tells me that a sub n plus 1 is less than a sub n for n greater than or equal to 1. Yes? So these two things together tells me that this guy converges. Yes? By the what? By the alternating series test.
So if it equals 0,
Yes. alternating series test. Okay, so what can I conclude? Is it's convergent. What type of convergence? Conditionally. And you might have one like this on the test, and you're gonna say, "Oh, this is gonna take so long," and all this stuff. But don't try to shortcut it. Okay, take your time. Do the process. You're okay. If it takes you 3 steps, okay, it's okay. Yes.
So like when I first went to the alternating series, will there ever be a time when is it equal 0 on the alternating series?
Yes. And then that guy diverges by the nth term test. Yeah. This is the alternating part. So what's left is that guy, if that's, yeah, what you, so you take the limit of the non-alternating part and you show it's decreasing to the limit. Okay, so final answer was that guy. Let's do another one. Same directions. Okay, it's just a continuance. Same directions. So it's saying, hey, is this absolutely, conditionally, or divergent, right? So when it's asking me if it's absolutely or conditionally convergent or divergent, the first thing I have to do is make a new series. Okay, so my new series. What's my new series become? Yeah. So there's my new series. And what happens here? There's my new series. So we said this guy does what? Converges by the p-series. Ah! Which tells me what? What absolutely converges? The original. This original, right? This guy absolutely converges. So that's what's so nice. If it's absolutely convergent, I don't have to go do the alternating series test or anything because I know that that would converge as well. Is that okay? Okay. So that's how we determine if it's absolutely convergent or divergent. But now let's go look at this next example to actually see what this means. Before we do that, tell me if this guy, is this guy conditionally convergent or absolutely convergent? Can you go tell me that real quick? You have plenty of space here. Go tell me what that one is. And then we'll go back to the question. converged by the p-series. So then I went back to the original series, and I saw that it converged by the alternating series. So therefore I can see that this guy is conditionally convergent.
Yeah, I was
Right here?
I didn't have the first.
one time. I was like,
I just got like the one, but then I saw it.
yeah, I just got the one.
Now we're good?
Yeah.
Okay. Okay, so we see that this is a conditionally convergent series. Let's keep that in the back of our mind as we go and do this next really fun thing. Okay. So they told me, hey, this guy right here, if I write out the first few terms, we can see, yeah, I agree with what they're saying. And they're saying they know from years of experience as mathematicians that this right here is a true statement. Okay? Do you agree with that? Okay. So what I want to do is I just want to rearrange the way that I put that stuff together. Okay. So I know that, hey, the ln of 2 has to equal, and I'm going to go odd, even denominator. Odd, even denominator. Commutative property. I can rearrange the way I add, right? Okay. So I have 1 over 1, odd denominator. Then I'm going to take the next even, and then I'm going to take the next even, which would be, yeah, negative 1. So I see all the even denominators are negative, all the odd denominators are positive, yes? Okay, so what's the next one? Let's do the next odd. 1/3, and then give me the next even. Minus 1, 6, minus 1/8. What's the next odd? 5th, and then the next two evens. And then the next even is? And it continues. Do you agree that that's exactly the same thing? Okay. So, you know what? I just want to add some of these together for fun. Okay? I'm just going to put these two, I'm going to add them together, and I'm going to get what? 1/2, and I'll just carry down the 1/4, okay? And then I'm just going to put these two together to get 1/6. I'll just bring down the 1/8. No big deal. And then I'm going to put these guys together to get 1/10. I'll just bring down that negative 1/12. Yeah? We said, oh, that was equal to the ln of 2. I said, well, you know what? I like to factor. I'm going to go ahead and just factor out a 1/2. I'm just going to factor out a 1/2 for my right thing. Okay? Factor out a 1/2, I get 1 over 1 minus 1 over 2 plus 1 over 3 minus, okay, right? Hold on. Okay, so I just found that this ln of 2 equals 1/2, and all of this in here, we already saw was what? We saw it right here, that that's the ln of 2. So, hold on. I can cancel out the ln of 2's, right? Okay. So, divide through by the ln of 2, I get 1 equals 1/2. Or multiply by 2, and I can show that what? I do anything mathematically wrong? Okay. That's additionally convergent. It means that the way that I rearrange things, I could actually get different sums. Okay, I could get it to be a half. So conditionally convergent means you can add it all up, and depending on how you add it, they can equal different sums for the infinite summation. Absolutely convergent means that it is just one sum. Can't change it. Pretty cool. Come on!
Oh, that was pretty cool, man.
It's just, but I mean, are you not like, that is awesome? Okay. But wasn't all of your days of suffering in calculus worth it for this one moment?
No.
Okay. So we're gonna just do a few AP ones together. No new skill, okay? Just practice. So let's practice some of these. You're gonna get pretty good. Oh, and by the way, you guys, this is gonna be on your AP test because this is a new component for AP this year. So this has been around forever since calculus, right? The whole concept, but AP is just now putting on absolute versus conditional. So basically means it will be on the test somehow. Okay? Because it's their first year that they're putting it in the curriculum. Okay. Okay, first one. I see, conditionally convergent, so I think first step is to do what? Make the new series. So let's go ahead and just make our new series for each of these. Make it for the first one. I think you're getting pretty fast at this, right? Can you guys skip the whole writing in the bars and just go to the series, or do you want to write in the bars? Okay, what's the series of the first one? What's the new series for the next one? And what's the new series for the last one? Okay, so those are my new series I'm looking at. In order to conditionally converge, that new series has to do what? Diverge. Does this one diverge? Okay, so that's a possibility. Keep going. Does this one? Oh, that converges, so he's out. Does this one diverge? Yep, so that's a possibility. Keep going. Now, do I have to write in by P series, by whatever right now? No, it's a multiple choice. We can know it in our head. Okay? We're under a time constraint. So now we have to go back to the original. So I gotta look at two of the originals. And both of those are going to be what type of test that I have to use on them? Alternating series. Okay, didn't show divergence yet. Show me anything yet. Is that a true statement? Do I have to go farther since it's a multiple choice here? No. Would you agree that this is true? Okay. So what did this one do? Converge. Okay, by that alternating series. So 1 is in there. Am I going too fast, or are you guys okay? Okay. Again, I see this. I'm going to use my alternating series. Got it to be 0, so far I'm not sure, but I didn't get divergent yet. And again, is that a true statement? Yeah. I don't have to keep going. Okay, this is just a multiple choice. So again, I got this guy too. converge. So that one is also conditionally convergent. So my answer is C. Okay. Okay, try the next one with your buddy. And I know you don't have to, but I want you to tell me how all of them either converge or diverge. Okay, on the new series part. Just so we're in the habit of knowing what's what. Is the new series okay? First one, diverged Y, it's the what kind of series? By a P series, but which one is it? It's the special one. It's the harmonic. Okay, so this one diverges by the P series. So that's out. In order to absolutely converge, the original has to converge. This one diverges by P series. That one's out. A couple things you could do on this next one, but I would pick the nth term. Right? So this one diverges by nth term. B's out. Last one. That's it. So that R is less than 1 but greater than 0 absolute value. So what does it do? Converges by the geometric series. So this one was absolutely convergent. Good? Here you can see it's new essential knowledge. Absolutely converge, conditionally converge, or be divergent. That is new, like I said. Okay, last one. I don't know why it has only, sorry. Only number 1. Okay. Or only number 2. And let's see if you can do the first one. Find out if it is conditionally but not absolute.
Oh, it's
Oh, that's okay. I understand. Thank you. Anybody write the new series first? diverges by the p-series, right? So this one would be absolutely, so it's out. So I can cross out one of the ABCDs. Okay, what about double I? Okay, so that one diverges by the p-series. So then we have to go and look at the original. What test will we use on the original? Alternating series. Am I going? Are you guys on that far, or? Okay. That conditionally converges. So now which one can I get rid of again? I can get rid of B. Last one's tough. Did everybody get 1 and 2 okay? Is everybody on 3? Oh, what are we going to do with this guy? What? That limit, though, is 0. Because it's bigger on bottom. So that doesn't tell me anything. Which one has the bigger denominator starting at the 2? This one has the bigger denominator, which would make it what overall then? It would be smaller, right? And this guy, the smaller one, does what? Diverges by the p-series. And so if the smaller one diverges, what does this one do? Diverges by the direct comparison test. Okay. So I know that it is not, Zach, are you okay? Okay. So it is not absolutely. So then I have to go to my original. Which one am I going to use here? Alternating series. Is that true for n greater than or equal to 2? Yeah, because that's going to give me a bigger denominator, which would make it smaller overall. So this guy again converges here by the alternating series. That one was a tough one, which would give me